this topic. Modeling and simulation. So, let's see. Hello? Okay. So, basically what I want to talk about today is this on the board, no? So it's more of sabi ko understanding, try to get our minds around the concept of modeling and simulation. Okay? And we're going to see some examples, no? Some crop model system examples and some, if we have time, agricultural processing examples. Okay. So, black box. So here, black box. Usually when you have modeling and simulation, you think of it parang black box, you know? There's an input, okay, some inputs, tapos mayroong outputs. What happens inside? Okay. So, ganoon din sa agricultural systems model, no? So it's like the same process, but this time we apply it to agricultural systems, no? Merong output sa input yan. Anong usually output? If you have an agricultural systems model, the usual output is the yield. No? You apply it on a field, gaano ba kadami yung maka-harvest mo. Ano kaya ang inputs? So their usual inputs are what crop, no? What soil, the weather, and the last one is management. So these are the usual inputs. Okay, so basically, if you have a model, you put this input and you let it run, and suddenly you have your yield. Okay. So, una-una, what is modeling and simulation? By the way, let's see, who has done modeling and simulation here? Present dito. About modeling lang, yung naglalakad-lakad, no? It's a different type of modeling. No? Basically, the modeling and simulation that I'm talking about is simply you capture the behavior of a system, no? Or process on a computer. Okay? And you capture only those who are relevant to your purpose. No? For example, kanina no, sa agricultural systems model, ano ba yung relevant? Yung output mo is the yield, di ba? So the only thing that you input are the only thing you put in your model are those that can affect the yield. Okay. It's based on scientific principles. That's the thing. Usually when you do modeling, especially in the sciences, you base it on scientific principles. And it's highly developed in the physical sciences. Okay. In the biological sciences, what do you think? Still catching up. Now, why do you think is the biological sciences is still catching up? It's basically because the biological systems are more complex. They are very complex. When you talk of physical systems like the model of, let's say, the solar system, no? Even though it's complex, the physics is not that. It's a bit simpler than biological systems. Okay? And usually it involves lots of calculations. That is why when you do modeling, you cannot do it by hand. I mean, in the modern sense, you cannot do it by hand. You have to use a computer. Okay? So tinanong ko na, have you done any modeling? Okay? So labo ko, labo ko. So engineer walk ako, no? Okay? So I'm going to talk about my background. Ano kasi, I was thinking about this talk. And basically, my background, yung binasa yung kanina, no? I'm an engineer, no? I do equipment design, basically. And I do the modeling to support the equipment design. Okay. Now, I also do food systems for space exploration. Okay. And part of it is molecular biology, no? Basically, if you're talking of food, you're talking of yung kalaban mo is microorganisms. So we have to study that. Now, just to tell you, no, I'm approaching agricultural modeling through my background as an engineer. So physical aking background. Okay? But I did some modeling on using biological systems. So this is a model. This is a growth model of fungi. So we developed one for using real-time PCR. No? And usually we want this because we want to study bioreactor design and also engineered consortia. Okay, basically engineered consortia is you were thinking if we're going to Mars, for example, no, you would need, let's say you want to make compost, you have to know how to put together all the microorganisms that are needed. So that's why we studied that. So these are my background. So basically, I was doing this, and then I was working with people in Cavite State University, and they introduced me to modeling in agriculture. Because they showed me this. Meron pa lang ganito. I think all of you seen this, no? Syngenta. This is a multinational company. No? They have this challenge. Okay? And there's prizes. No? $5,000. First place, second to 5, third place is 1,000. This was in 2019. 2019 yung sinabi niya, now this is the challenge. Okay? So basically, this is a model, a modeling problem. Okay? So there's the word model there. So I got into agricultural modeling through, because I looked at this. Sabi, salin daw kami, no? Baka matulungan ko. Okay? So that was 2019, no? Tapos nandun yung 2019 winners eh, sa taas. Pag pinik natin, hindi wala ka doon. Hindi kami sumali na because it's a little, medyo, there's a lot of work you're going to find out. Making a model takes a lot of work, and usually if you don't have an educated team, it'll be hard to do that. And, okay? So let's talk about, so ito yung, just one thing I want you to see, no? When you're talking of modeling, usually you're working with computers, and when you're working with computers, you need software. Okay? Now, there's a lot of models already. Some usually, siguro, if you do research in agriculture, you might end up using some. So this one is, if you search on the web now, this is APSIM, Agricultural Production System Simulator. Okay? So it simulates biophysical processes in agricultural systems, and you relate economic and ecological outcomes based on, okay? Yeah, so basically these are the uses of a model. Okay? And so APSIM, you can look at it online, APSIM. And the APSIM modeling framework, this is, I'm talking of APSIM as an example. I want you to see what the model is. Now for agriculture, there are usually these parts. Remember, no? There's biophysical modules, management modules, input and output modules in a simulation engine. Okay. So those are the things that you always find in an agricultural systems model. And so ito yung kanilang magandang they have this sort of, if you look, this is from their website, just Google APSIM and you'll find a lot of this stuff. Now, basically, they have parang jigsaw, no? They say this is the modules. Okay, they come together to make your model. And there are crop modules. What you're going to see is every crop has its own model. So you have to find, let's say if you're interested in rice, so rice, no? Okay. Yeah, rice at 2000. I will talk more about that because that's developed by Balik and rice. Okay. And so again, let's go back. Capture mod. Okay. So yeah. So just for you to remember again, what is modeling and simulation? Basically, it's you try to get the behavior of something in your system. There's a behavior of a system. Okay, scientific principles and involves tons of calculations. So we'll go a little bit deeper now. What is the system? What do you think is a system? When we say system, basically the system to be modeled is defined, we define it to study a part of the real world. Right? For an agricultural model, it would have components, interrelationships among components, and okay, so you have your cropping system model. So what do you think is in your cropping system model? Okay, this is a typical. You have your system boundaries, so you have your plants and your soil, and you have the environment. Okay? So this is how you sort of organize your system. Your system is crop and soil, and you have your environment surrounding it. Okay. And your mathematical model, mathematical representation of the system, okay, you have interrelationships among your components, the environmental effects, equations of processes that cause change. Let me just show everything here, no? And take a moment to read them para makita niyo yung whole thing. No? It's basically, the idea is you have mathematical representation. So, pag sinabing mathematical, what comes in your mind? Numbers, no? There's variables, there's equations. Okay? So that's what this tells you. Okay? And usually there are assumptions. And that's usually where the models differ. You know, what assumptions they put in there. Okay. So simulation, what's simulation? Simulation is the numerical solution of the model. So you see what's happening, no? I'll show you a diagram later, but modeling is simply trying to put your system, describe your system mathematically. Diba? What's simulation? Simulation is solving all the math. Okay? And usually that's where the computer comes in. Okay? So you see, no? So those are just the details, but the big picture is there's a system, you make a mathematical model, okay? And then you solve it, that's a simulation. And you can see, no? Okay, ano ba mahirap dyan? Basically, you can see that everything actually is done in the computer except for the last one. What's the last one? That's validation. You have to compare with experimental data. No? So, you cannot say that you made a model, you run it, you have all these numbers, but it doesn't mean anything much until you compare it with experimental data. Okay? So this is it. So ito, no, it's sort of a diagram I found on the web. I just can't forget where I found it. But basically, you start with the real world problem. Okay? You simplify, you get the real model. So how do you get the real model? Usually it's based on scientific principles. Okay, it will involve relationships among variables, mechanistic and functional. Remember this, huh? I'm going to talk a little bit more about mechanistic and functional. Because usually, this is where the difficulty is. How do you relate the variables? Okay. And there are assumptions. When you get your mathematical model, sabi nga, it has variables, it has equations, and usually the equations are differential equations. Who has calculus already here? Okay, calculus is basically, I mean, if you have dynamic models, you have differential equations. And usually this is not the problem, because the computer will solve it. Computer will solve it. And in the end, you have the solution, but you would need to interpret. That's where your expertise comes in. You interpret the solution. And hopefully that will solve your problem. And among this, I think most of you are agriculture, no? Or environmental. What would be the most important part of it? What part? Basically, this part, no? Making the model. Because that's where the knowledge comes in. That's where a lot of the knowledge comes in. Once you have your mathematical model, this is basically just solving the equations. So there are programs na. There are programs that you can use. Even though it's important. It's important. Okay. So question, why do we model? Okay, aside from, I don't know, sometimes you get this particular tawag dito, yung contentment or satisfaction that there's something in the real world that you can make run in your computer. But basically, scientific understanding. Okay? And the other one, oh sorry, oops, I killed it. Ikaw na lang, ha? What happened? Okay, so while we are, sir, napindot ko na? Meron palang blackening doon. Okay. So, let's take a look at this, no? On how you model. So basically, these are, what do you think, are these good enough reasons, no, to doing the model? Basically, it's scientific understanding and for decision or policy support, especially now, no? Because of, okay, climate change. So that's another one. So you want to know what happens if climate change happens. For example, what will happen to the plants if carbon dioxide goes up? Okay, so we want to see that. And we are in a good time, no, to do modeling because there have been 3 developments actually. Number 1, you have the numerical methods. Like what I said, you can solve the differential equations using your computer. And you have an expensive computer. It's very powerful. Yung mga laptop na to, it's like before, if you remember, no, they have this big rooms with computers. But now, you have the same power with a small computer. No? And you have your software packages. Okay. And an example really of modeling is this. Bago pa to, mainit pa to, no? This is Jenny Dam. This is the tropical depression. Nasaan na ba siya? Dito, no? Eh, binasa ko na nalang palang pasok sa Metro Manila because of anticipation. So, it's going to hit the Philippines. And you can see there's August 29, no? There are predictions. So, these are predictions are done using models. Okay, these are using models. And you can see there's uncertainty. No? This one, they call this the cone of uncertainty. That happens because the model has, there's some assumptions. And ano ba isa namin ng model? Weather, and the other one is the climate. That's why your generation talaga will feel this, no? What's going to happen to the climate? You will see that there are projections, and how do they make the projections? Through models. That's always through models. Okay? And you verify it. So you can just read it, but basically the models have to be verified. Kita niyo dito na there's some verification and validation. Okay? And now we go to general methodology. So how do you make or do model? Basically you start with theory and experiment. So you have data. You always start with data when you're going to model something. And there's usually some theory that explains the experiments a bit. And then you make your model. There's a computational model. So what's the difference? The mathematical model is the math. Computational is trying to put the math in the computer so that it can be solved. And you run it, you get results, you verify and validate, and then you get, again, you change the model if the experiments and validation do not agree with each other. Okay? So you see that. That's your general methodology. So now I think we're going to go to the examples. So far. So what do you think, no? Medyo mabilis, so parang very crash course on how to model, but at least you know what a model is. A model is simply, you try to represent your system in your computer. So crop road models. Okay? So remember what we did, no? You put your crop soil weather management into your model and then you have your yield. So what's a common example? There's the plant growth model. Okay. So how will you model plant growth? Sa tingin nyo, no? The way they model plant growth in most of the systems are this. First, you have defining factors. So potential. So basically, if you give a plant, in this case, it's a corn, no? All the carbon dioxide, the radiation, the temperature, and its genotype, no? It will grow to a certain level. That's the basic modeling. Now, then you add the limiting factors. So you try to see what will happen if the plant grows under conditions where there's not enough water, not enough nutrients, what happens? So So those are limiting factors. Okay? And the last one are reducing factors. If you have weeds, pests, diseases, and growing plants. Okay? So you can see, no, just modeling the growth of a plant is medyo complicated na, di ba? It's complicated. You have to know, no, the biology and how these factors affect your plant growth. Okay? And this is really what I want to push. No? Because at this point, what I want you to really take away from this lecture is that, or this talk is that, this is really, as scientists, no, this is where we come in. How do you get the mathematical equations for the model? Right? How do you get the mathematical equations? So in general, how do you get mathematical equations? Basically, you do experiments, but yeah, so let's talk about this. This is usually something that I ask people, no, or ask teachers. No? If you model plant biomass, tingnan niyo yung tree, no? So anong sagot? A, B, C, D. A, B, C, D na. No? What do you think? Where does most of the biomass come from? Okay, so think about your answer, no? Bukaba ba tayo na yun, no? Volunteer. Sino may volunteer dyan? Sigurado sa sagot nila. Kilala ko ba? Pag na lang, sige. So, tanong ko na lang, taas ng kamay. Baka nahihayin din eh. Taas kamay, huwag na baka mahiya pa eh. No? Kasi mahagri sila, dapat na lang nila ito eh. No? The answer is the air, di ba? Tama ba? What process is that? Photosynthesis, no? Di ba? I mean, that's the thing, no? Parang ang dali lang. But usually, when you model something, okay, you have to be aware, no, of what's happening. Now, the problem really is that this is a very nice equation, no? Pero basically, if you think about it, the equation is sort of a summary already, because what really happens if you do your biology or plant biochemistry, you're going to see that photosynthesis is really very complicated. No? So, kung gusto mo mag-model, you have this thing. No? You derive equations for all the processes. You see what I'm trying to do here, no? There's photosynthesis, and it's a complicated process. So how do you get the equations to describe photosynthesis? You derive equations for all processes. That's one way. And usually we call that the mechanistic model. Pag mechanistic, what does it mean? It means you consider the mechanism. So how the thing is happening, how things are happening. That's mechanistic. Okay? Now, this is why it's hard to model biological systems, because it involves lots of steps. Mahirap siya yung model. Okay? So, this is what you do in biochemistry. Just to illustrate what I'm trying to point out here. In biochemistry, you have this, you know enzymes. So you know enzymes naman, di ba? What are enzymes? So biological catalysts. So this is a common, one very simple chemical reaction. Glucose to fructose. Okay? This is how you produce high fructose corn syrup. Fructose is sweet, very sweet. Twice as sweet as sucrose, so yung common table sugar. Okay? And you have your glucose isomerase. Okay? Now, if I ask you, what's the effect of concentration of glucose on the reaction rate, meaning how fast the reaction happens at constant temperature? So, usually, if you have this kind of question, you get data. So, this is data. Okay? So, glucose concentration versus rate of reaction. Now, let me ask you, based on this data, can you get a relationship, a mathematical relationship? Yes? I mean, you know Excel, di ba? Okay. So, if you have this, you can do what's known as a regression. Di ba? Regression fit. No? And you have parameters. So these are some things you will be hearing when you look at models. So there are parameters. Okay, the parameters are simply the numbers in there. X is concentration, Y is the velocity. Okay? So it looks like a good fit kasi 0.994 yung R squared, no? But you will see that there are some parts that's not really good, no? But it's a good fit. Okay? That's a good equation. Now, this is what is known as a functional model. Basically, it's regression. You just regress. But you try and fit an equation into the data. But let me tell you another way. Who's taken biochemistry already? Who has heard Michaelis-Menten? Michaelis-Menten. So, there's an enzyme mechanistic model. Basically, really what happens is E is enzyme, S is substrate. So there are reactions involved. And you have this, the Michaelis-Menten equation. It's an equation for the rate. It's mechanistic because it's based on what's really happening. And if you do the plot, you can see that it's a good fit. It's actually a fit niya because for this system, you have a mechanistic model. Okay. Oops, sorry. It's a mechanistic model. Now what's the point I'm trying to say here is that usually you can get an equation two ways. What are those two ways again? One is functional, but you just do regression. You do regression, best fit. And the other one is mechanistic. Mechanistic is you try to think of how the process is happening and try to derive the equations from the process and see if it fits your data. So that's your model. Okay, so this is a mechanistic model. Now, which one do you think is better? Basically, if you think about it, the mechanistic is a lot better because it tells you what's happening. And also there's this thing. The parameters, okay, here have meaning. Kasi they have meaning, the parameters. Ang problema kasi dun sa isa, I'll go back now, sorry. The parameters really have no physical meaning. They're just fitting, they just fit. Okay? You can try and think of physical meaning, but usually based on what you did, there are no physical meaning. So basically, you don't know whether it will change or not if you change your data. Yeah. So, let's go back to photosynthesis. Now, photosynthesis usually is model functional. So, let me just show you this. This is just photosynthesis, just one thing that's happening in your plant, photosynthesis. Kita nyo, it has how many functions in there? 1, 2, 3, 4, 5, 6, 7, 8 functions, And these functions are based on certain factors that affect photosynthesis. Okay? And let's just take a look at one, the LAI, leaf area index. Okay? So usually they have this plot. Now this is experimental, and you can model it using this. So there's an equation that you can get. However, you can see that there's a parameter K in their equation. So this is a functional model. Okay? So that's the thing. That's what I want you to see. Because it's difficult to make mechanistic models, most of the models are functional. That's why I don't have a slide for that. But if you do agricultural modeling, there's always this first step where you have to calibrate your model using data that you have for your crop. The calibration, what's the calibration for? It's basically to get the parameters that you're going to use for your model. And just to point out, this is also good in biology. They've been using it for biomedical systems. So they have this. I'll let you read this. So basically, may gene-based testing na raw for heart disease, breast cancer, and others. Sounds good, di ba? Kaya lang ang problema, if you take a look at it, ilan daw ang kanilang kailangan tignan? 6.6 million spots in your genome. So that's really that's what I wanted to see. No? That's for most models, if you're doing functional relationships, it really is some systems, napakadaming factors, no, that affects it, like us, no, humans, or this kind of thing. Okay? And it seems weird, but someone did it. No? They looked at 6.6 million genes, no? It's high throughput, and they were able to find out that a combination of them can tell you whether you have this risk. Okay? So, just to show you one more model. No? So, that's what I want you to see, no? Because there's not much time, but I want people to see right now, or want, para kasama sa dito yung ating awareness, no? That when you have a model, it's usually as good as the relationships between the variables. And usually the relationships among the variables is either mechanistic or functional. If it's mechanistic, it's a lot better. Okay. So this is the rice model in theory. Okay, so this is usually what it can do, no? So usually it's the same, more or less, typical of your agricultural models. Okay? And then this is your typical, what you see is a typical flow chart. You can see what factors are involved in the system. So just to show you some typical symbols, no? Yan. The squares are levels of your variable. Kita nyo na, the variables are biomass. Ito, no? Biomass in the leaves, stems, panicles, or roots. Okay? And then this one, they call this a valve. No? It's a valve. So it's like the rate. Okay? So how fast is photosynthesis happening, development, growth, maintenance. Okay? And this are material flow, these are information flow. So so that when you see a model, you can more or less understand what it's saying, how they designed it. And you can go online and try it. Kaya lang, I warn you na napakadaming, there's a lot of inputs in the module. So really, it's a bit involved to do a modeling for agricultural systems. And they validated Arquiza. You can see the validation here, no? They have, the newest model is version 3. This is the older model, and there's an improvement. This is 15%. Usually this is a typical model validation diagram. Kita niyo yung this is simulated. This is what the computer gives you. This is the measure. This is the experimental. So, if they consign, kunyari 100% ang kanilang agreement, they will all be on the, what's this line? The 45-degree line, no? The x equal, y equals x line. Okay? And you can see that there are some variations. Kaya lang, they have 15% variation, so 15% of the value. So kita nyo, it goes up kasi the bigger the value, the bigger is the 15%. And they find out that most of the data is within 15%. So this is a good validation system. So, I think that's the only slides I have for now, no? Because, anyway, time? Oh, do you have time? Bilisan na lang daw. Kasi it's, most of the system is on validation. Remember the setup I did, no? When you have when you do your simulation, you have the math equations and susunod. You try to put the math equations into your computer, and then you run the computer program. And when you're running the computer program, what do you call that? That's a simulation, right? And then after that, you have to verify and validate. Okay? And if there's something different, you have to change your model. Okay? So what's the hardest part, again, when you are doing modeling? Yeah, getting the relationships, no? Among the variables that you are involved in. That's why usually the best one is mechanistic. So you have to know your biochemistry, chemistry, biology, etc. But if you have data, you can do regression. Okay, you can do regression. By the way, you heard of big data? Diba? Big data modeling. Big data also uses models. Pero what do you think is the process behind big data? Is it functional or mechanistic? Basically, it's just regression. No? It's functional. That's why I guess they say that's the way the world is now. No? Because there's too much data, you can just regress it and then you'll get meaningful equations. Kaya lang, the difficult thing is that you don't know whether the relationships are really good for all, no? All types of data. So, baka it may fail sometime. I think it's... Okay pa ba? Okay pa na. So kasi the next slide kasi is agricultural processing eh. So it's a little parang medyo, just to show you, I've also done this kasi. Agricultural processing is not as hard as agricultural systems modeling because, again, let's go back to my background. I do food for systems for space exploration. And when I went back to the Philippines in 2015, no, it was just after Yolanda. So we were all looking at this. No? Parang sort of na highlight yung problema sa Pilipinas na every time we have evacuation. No? Every time something disasters happen, kahit man-made disasters like in Malawi, no? There's always evacuation. So we were thinking, kasi I work with space food. This is the typical space food, no? Okay? Maybe we can change them to food for disasters. So that was the idea. Okay? And basically, we focus on this part, the add water. These are freeze-dried. But we're not going to use freeze-dried because freeze-dried is expensive. Yeah. Okay? But basically, these are vegetables. So these are, kasi dito, these are sterilized. No? So this is usually good for meat. No? Pero pag agricultural products, you don't sterilize it. Kasi ano ang problema? Mag-sterilize ka ng repolyo, ano mangyari? Malabsak na, no? So it's not good. Okay? So, yeah, so this is typically what I do, no? Eating rice on Mars, pre-packaged, ano pa kaya pwedeng gawin? If you're going to Mars and you want to eat rice, pwede ka magbaon, pwede ka magdala ng bigas, no? Tapos rice cooker. Ano pang isang pwedeng gawin? As agri, yeah, no? You bring everything so that you can plant. Okay? So that's the thing. And I work on this, the middle one, but I also did some work on this part. No? Kasi if you're going to be producing crops on Mars, you definitely need, yeah, so they do plant experiments from NASA, no? Since you're producing crops on Mars, definitely you need a dryer. No? Kasi walang ref sa Mars. You're not going to have a refrigerator there because refrigerators take too much energy. Yeah? So the best way to preserve whatever you produce is by drying. Okay? And when we went here in the Philippines, when I came here back to the Philippines, no? So we sort of built a similar dryer. No? Okay? And then, so if you're talking of drying, you dry mango. So we dried mango, and this is our system actually. So there's no heating. So we try to preserve the structure of the fruit or the vegetable, and we also preserve the vitamins. Okay? So there's a lot of dried products that we tried, and what we found out is that you can rehydrate it. Pwede siyang ibalik. No? Parang freeze-dried, no? You can rehydrate it. Because our system is low heat, no? Halos walang heating. And when you have rehydratable vegetables, students, what is this useful for? Siyempre, instant noodles. No? So we find that. So we have that. Okay? So we have this. So I'm going to talk about modeling because basically, so we have this last year, no? And then we want to, it's the scale-up problem. Really. That's a problem in the Philippine agricultural process, or any type of processing in the Philippines. We are very good in making a small one, but it's hard to scale up. We call it the scale up. No? And the best way to scale up really is to make a model. So that's the use in engineering, the model. So it's different than agriculture. Okay? So just show you the model. No? You have airflow, and this is side view. No? So this is top view. So side view, kita nyo, no? And then you can do this. So just imagine this. No? This is the side view of your mango. This is moisture content, 70% moisture content at the start, time equals 0. And we're going to blow the air over this. So what do you think will happen? It will dry up. No? If you make a model, you can simulate that like this. Tignan nyo, no? Take a look. Okay? So nagbabago yung color, no? And that depends here. So you can see the moisture content goes down quickly on this side. Okay? And in the end, it stops after this time. No? So that's about 6 hours. So this is validated by experiment. Okay? So that's the thing. Now, what is this useful for? For example, the size of this one is 2.54 centimeters, 1 inch. Let's say a customer wants 2 inches. Yung haba, no? You, as the one who has this facility, tatanungin ka, gano'ng katagal magdadry yung doble ang haba? Sa tingin niyo? So ito. Okay? So yung 2.54, 6 hours. Yung 5.08, that's twice this, no? 2 inches. Gano'ng katagal? Okay? So, kung wala, no, pwedeng definitely more than 6 hours, but baka less than times 2, no? 12 hours. But to know for sure, you can do it. So you make a model again, no? You run it. Tingnan natin. So you see it's the same thing, no? The drying is happening from the right, or from the left, no? If you're looking at it. And in the end, it is 8.5 hours. So it's a model, actually. It's simulation of drying. I mean, it sounds simple, no? Very simple, but this is hard. No? So tricky to do this. But the good thing is, once you have the model, no, you can, let's say, customer wants this to be double thickness naman. So ilan na? 1 centimeter. So what you do, you go inside your computer model and change the size and run it. Okay? And your simulation of airflow also, so you can simulate the airflow. And basically you can do virtual prototyping. So that's actually the use of modeling in the engineering. So the virtual prototyping. Okay? So I guess that